Okay, here's a quick review of the Mod 3 Chemistry Quiz 1. Some of you did very well, others of you really struggled, so let's go through it real quickly. How many moles are contained in 36.5 grams of copper? So the question is, how many moles of copper are in 36.5 grams of copper? You look at your periodic table, you see that the atomic mass of copper is 63.5 AMUs. Therefore, a mole of copper has a mass of 63.5 grams of copper. The molar mass of copper is 63.5 grams. Remember, molar mass is just the atomic mass of the element expressed in grams. All right, makes a wonderful conversion factor. Grams on the bottom cancel grams on the top. And that gives us 36.5 divided by 63.5 moles, which to 3 sig figs is 0.575 moles of copper. So that 36.5 grams of copper represents 0.575 moles of copper. Remember, mole is how we count in chemistry. A mole represents a certain number of, in this case, atoms. So we're able to go from mass, which is something we can measure in the laboratory, for example, the lab we're doing this week, and we can figure out moles. All right, turn it around the other way. How many grams, so that's mass, are in 2.35 moles of silver? So how many grams of silver are in 2.35 moles of silver? Again, silver has the symbol Ag. Some of you are confused by that. So now if I look at the periodic table, a mole of silver has a mass of 108 grams. So almost did it wrong. There are 108 grams of silver per mole of silver. So again, molar mass of silver is different than molar mass of copper. Silver atoms are larger than copper atoms. Moles cancel moles again, lovely conversion factor. Now I'm going to end up with a mass, and 3 sig figs. I take 2.35 times 108, and I get 254 grams of silver. So 2.35 moles of silver, okay, which is a number, is equivalent to 254 grams of silver. So if I, for some reason, needed 2.35 moles of silver, I would have to weigh out 2.54 grams of silver. Okay. How many atoms of zinc are in 65.4 grams of zinc? How many zinc atoms are in 65.4 grams of zinc? So I'm starting with a mass. Okay, I want to get the actual numbers of atoms. I look at the periodic table. A mole of zinc just happens to have a molar mass of 65.4 grams of zinc. Isn't that nice? Grams cancel grams. Then I want to go all the way to the actual number of atoms. I know a mole is defined as 6.02 times 10 to the 23rd atoms, in this case atoms of zinc, per mole. A mole of anything contains 6.02 times 10 to the 23rd things. And when I do the calculation, 65.4, notice moles cancel moles, 65.4 cancels 65.4, and that 65.4 grams of zinc represents 6.02 times 10 to the 23rd zinc atoms. Okay. Now we're talking about compounds. How many moles of sodium chloride, NaCl, are in 454 grams of NaCl? So I look at my periodic table, okay, and I take the mass of sodium, which is 23.0, molar mass of sodium, 23.0 grams per mole. I take the mass of chlorine, 35.4 grams for chlorine, add those together, I get 58.4 grams of sodium chloride per mole. Okay, so my conversion factor, 1 mole of sodium chloride is equivalent to 58.4 grams of sodium chloride. And again, grams cancel grams. If I do that calculation, 454 divided by 58.4, I get 7.77 moles of sodium chloride. Similar problem, I've got a compound, covalent compound now, sucrose. I've got the formula C12H22O11. I want to know how many grams of C12H22O11 are in 3 moles of sucrose, table sugar. I need the molar mass. So I'm going to take 12 times 12 grams for the carbon. I'm going to take 22 times 1 gram for the hydrogen. And I'm going to take for the oxygen, I'm going to take 11 times 16. When I add that all up, thank goodness for a calculator, I get 342 grams of C12H22O11 per mole. All right, so come back, use that conversion factor, 342 grams of sucrose per mole of sucrose to 3 sig figs, 1.03 times 10 to the third grams of C12H22O11. Okay, continue on. Number 6, octane is one of the hydrocarbons in gasoline. Write the balanced equation for the complete combustion of octane. Again, combustion means combining with oxygen. We looked at these in class. O2, oxygen is one of our diatomics. The products of that reaction, complete combustion, are going to be CO2 and H2O. Now we're going to balance the reaction. Put a 2 here. I'm going to put a 16 here. I'm going to have to put a 9 here. Excuse me, I have to put an 18 here. All right, and then if I add it up, I've got 50 oxygens, so I need to put a 25 here. There we go, it's a balanced reaction. 16 carbons on this side, 36 hydrogens, 50 oxygens. On this side, I've got 16 carbons, I've got 36 hydrogens, I've got 50 oxygens. That is a balanced equation. Okay, finally, I've got a gallon of octane. This relates to the problem that we did in class when we were calculating how much carbon dioxide Zach would produce if he drove his Prius from Pacific Palisades to Vistamar. All right, how many grams of carbon dioxide would be produced by burning 3 kilograms of octane, C8H18? First thing I want to do is convert that to grams. 10 to the third grams per kilogram. Love the metric system. 1 mole of C8H18 has a mass of 114 grams of C8H18. Again, if you add up 8 carbons and 18 hydrogens, that's what you get, 114 grams per mole. So grams cancel grams. The balanced equation up here now tells me that I get 16 moles of carbon dioxide produced for every 2 moles of octane that burns. So moles on the bottom, cancel moles on the top. And then finally, do that down here, if I add up a carbon and 2 oxygens, there are 44 grams of carbon dioxide per mole of carbon dioxide. Moles of carbon dioxide cancel moles of carbon dioxide. I've got grams of carbon dioxide. I'm done the problem except for the trivial part of doing the calculation, and to 2 sig figs, 9.3 times 10 to the third grams of carbon dioxide produced if I were to completely burn that grams of octane. All right, so look this over. I hope this helps those of you who had some trouble. I hope you'll take advantage of the do-over possibility. All right.